If you're using Turbo Intruder within Burp Suite, chances are you want to send a lot of requests as quickly as possible. In previous videos, we looked at setting up and using Turbo Intruder for some basic attacks. In this video, we're going to look at optimizing the speed of those actual requests so that we can send many, many requests, get many, many responses as quickly as possible. As you can see here, we have Portswigger's intentionally vulnerable web application, Gin and Juice Shop, ready with Burp already open on the right-hand side here. And what I'm going to do is actually just refresh this page here first. I'm just going to intercept a request for the search function within the blog. This isn't really a practical attack. We're just looking at ways to optimize the speed of requests that Turbo Intruder sends. We're not actually attacking something with some end goal. So it doesn't really matter what function we're looking at. We're just looking at the search because it's a simple function that we can play around with. So I'm going to right-click in the request and send that to repeater here. Going to click send. And so we can see the result that we're expecting from this search. The first thing that you want to do, and this comes from a list directly from James Kettle in his article about Turbo Intruder and optimizing it for speed. The first thing we want to do is actually minimize the size of our HTTP requests. And of course, this makes sense when we're sending many, many requests. We are going to be, if we're sending HTTP headers or parameters that we don't need to be sending, we're multiplying, that extra amount of data per request and ultimately going to be slowing down our attack overall. So we want to minimize the amount of data that we're sending over the network so that we can send more of the data that is actually important to us that, we need to send for the request to succeed. And you can go through this request and you can delete headers and look at the results and see if there's any change. But you can also use an extension that's available within the BAP store. So if I go over to extensions, you can see that I already have it installed. This tool is called Request Minimizer. It's quite handy. I can right-click within this request, go to Extensions, go to Request Minimizer, and I'm going to click Minimize in a new tab. And it's going to take a quick moment here to do that because what it does is it runs a repeat request where it removes a different header each time to find the minimally viable request that we can send to still get the same response. And as you can see, it just contains, the top line and then the host header here. And we get the results that I think we expect. We don't really care for the purposes of this demonstration. If you look in Logger, of course, you can see that extension in action where if we go through time looking at the different requests that it sends, it successively removes headers and compares the responses to make sure that it's still getting the same response. So now we have a significantly smaller request size. Now that might not make a huge difference practically for this attack here because the response is still very long. So one thing that actually didn't come up in James Kettle's article, which I will link in the description of this video, is another thing to consider is crafting your request to modify the response size to make your attacks a little bit more efficient. And this is really going to depend on the functionality that you're looking at and what you can do with it. There might be ways in which you can change the nature of the request to change the resulting response size while still being able to conduct the attack that you want to accomplish. And I can't speculate as to all the different conditions that might allow that. But some cases might be, for example, a database lookup where you're enumerating something and you could actually refine the number of attributes to return less data than you actually need while still exfiltrating what you do want to exfiltrate or enumerating what you do want to enumerate. So especially if you're trying to conduct a really large attack, it really makes sense to take some time to think about the attack if you're going to be sending millions of requests and trying to reduce the size of those requests and the responses while still making it a viable attack. Another thing that you can do is modify the HTTP methods. So for example, depending on the type of attack that you're running, you might find that the HTTP head method is more appropriate. In this case, we get actually a very different response. So if we were doing a practical attack, it probably wouldn't make sense or work for us, but it might work in whatever you need it to work for. Another thing to point out is the Accept-Encoding heading was another item called out in James Kettle's article, and he didn't go into detail, but I think what he was referring to is the compression, HTTP level compression. And I'm actually not sure what's efficient. I haven't experimented with it yet. I might at a later point. The question, I guess, is can you send a lot of requests and get a lot of responses faster when you're using compression, which is going to optimize towards the, it's going to decrease the data that you're sending over the wire? Or is it faster to not use compression and save those compute cycles and doing the compression? I'm actually not sure. I haven't investigated it, but it's something to keep in mind. Again, especially if you're conducting a very large attack. We're not going to play with that. We're not going to go into that level of detail for this video, but something else that was called out by James Kettle to keep in mind. We're just going to use this base, very simple request here. And now we're ready. We've got it set up, ready to go. Actually, I am going to use the GET request. And I'm going to right-click in the request, and finally, I'm going to send it to Turbo Intruder, which you'll see that the variation I have installed is Turbo Intruder with haptic. You can use the regular Turbo Intruder from the BAP store. That's totally fine. It's going to be the same for the purposes of this video and for optimizing our attacks. So you'll see here, the last code I was using that opened up by default is actually just basic.py. So if you're following along, you can use the default example from Mr. Kettle. In this case, it sets up a very standard attack, and the point that we're really concerned with to start out with here is the configuration of the request engine. So that's going to be determining how the engine actually handles sending and managing the HTTP requests that we are creating. So that's what we're going to focus on to start here. And you'll see it gives us a default configuration with a set number of concurrent connections being 5, a number of requests per connection being 100. So I believe it's reusing TCP connections, and whether or not to enable pipelining, which currently is set to false. Now, there is actually a default attribute here that is missing from this that is important to keep in mind, because it's also going to be important to optimize your attack, and you are going to want to play with it. And that is the actual engine that is being used. And it's not listed here because there is a default, and I had to take a look to see what the default was. So here is the code for setting up the script environment within Turbo Intruder. And you can see that there are a number of different class engines that are defined. The first one is burp. There's one called threaded. There's one called HTTP2. There's one called burp2, and there's one called spike. Spike, that last one, is the one that I haven't played around with. I didn't look into it. I know nothing about it. I encourage you to take a look and maybe post about it. But for now, we're going to ignore that one. But if you look down at the initialization of the request engine, you'll see that it's using threaded by default, right? So including this, setting it to threaded is going to be the same as having it unset. So let's go back to our attack here, and I'm just going to add a line here where I set the engine to engine.THREADED, and that shouldn't have any impact because that's a default. So one way that you can start looking at optimizing your attack speed here is by starting with the slowest possible attack and just trying to ramp it up from there. And following this approach, which of these parameters you're going to be manipulating is actually going to depend on the engine that you're going to be using. So the engine is the first thing to consider. Now, in Kettle's article, he recommends using first, and stand by while I pull it up again, the HTTP2 engine. So let's actually go back to the list. So he recommends first HTTP2, then he recommends threaded, and then he recommends burp2, and then he recommends burp as the preferred order. Now, what you're going to be able to actually use in practice is going to be, it's going to depend on the server you're targeting. For example, some of those engines use HTTP2, for example. So you'll want to, and some of them use HTTP1. So you'll want to first determine what the server you're targeting supports. And if it supports HTTP2, you're probably best to go with the HTTP2 engine because that's the #1 recommendation for efficiency. But the threaded is the default and is pretty fast in and of itself. So we're going to experiment with that first to look at the parameter optimization If you want to know how to check whether the target server supports HTTP 2 or HTTP 1.1, you can go back to Repeater and open up Inspector and pull down request attributes, and you can send a request with, of course, we're sending HTTP 2 right now. Click the HTTP /1. Now we're sending HTTP 1.1, and you'll see that we get a response from the server so that we know that it also accepts and handles HTTP 1. So we can do both attacks. So let's go back to the setup of our attack here. Very simple attack. Everything should be, this should be the slowest possible attack that we can run. I click the attack button. Actually, one thing I didn't do, I need to configure this real quick, is I'm just going to, in the search parameter, just drop in our payload position, just so we have that going somewhere. And then I click attack. And the important attributes to pay attention to are down at the bottom of the screen here. So you're going to want to look at RPS, which stands for requests per second. You're also going to want to look at retries and failures and fails, which obviously are things that we want to avoid. So we want to optimize RPS, right? We want that to be a large number. 2 requests per second, as you know, is not a large number, or as you ought to know if you're at the point where you're using Turbo Intruder. So we want to pump those numbers up. So let's halt that attack. Let's go back to configure. And what we want to do here is fine tune these different parameters. Now, the recommendation for the order with which to modify and refine these is to start with pipeline. So let's turn that on. So pipelining, which was set to false, and now I set it to true, is an HTTP 1 feature that isn't always supported. It doesn't have a wide support, but some servers do support it, and Turbo Intruder's threaded engine does use it. So it is one way that we can more efficiently send requests if there is support. And then we also want to look at requests per connections and turning that up. But let's just first look at pipelining on its own, which I think probably is going to yield about the same amount of time, and surely it does. So let's halt that. Let's go back to the configuration. Request per connection. Let's turn this up. Let's set this to 10, for example, and let's hit attack. And look at that. We have a much higher request per second. Now it's at 10 requests per second. So let's halt. Let's configure. Let's try 100. Can we take it to 100? Click attack. And what do we get? We didn't get quite the same scale of improvement. We have about 24 requests per second. So let's halt. Let's go to configure. What happens if we try 200 requests per connection? And we click attack. And we did a little bit. Okay, we're doing decently well, just under 50 requests per second or right around 50 requests per second. But it's still not very fast, right? So we want to play around with some of the other parameters like concurrent connections. And this is the approach that you really have to take in practice because there's no method currently to kind of automate the optimization of these parameters. And I suppose in theory, Turbo Intruder could be built to do that. The feature just hasn't been built in. Hey, if you're an inspiring tool developer, maybe you want to try your hand at adding a feature to Turbo Intruder and making it so that it automatically determines the optimal parameters by this sort of, basically following an optimization function. But for now, basically, we go through this. We are the optimization function ourselves, where we modify the parameters, run the attack, and see how fast it gets. So now let's modify concurrent connections, which is the last item that we want to modify. And just as a side note, from some of the literature I've seen, the recommended request per connection usually varies between 50 up to like a few hundred, and concurrent connections usually less than 100. So I'm just going to put that up to 10 for now, and then run the attack again. And let's see if it goes a little bit faster. And look at that, it goes way faster. So we're getting a few hundred now quite easily. So let's go and configure it again, change it to 20, and attack again. And what do we get? It's going even faster. And we're not getting any retries or failures. So let's go back and let's increase it again. And this is the process, right? This is the process for you to optimize the speed of your Turbo Intruder attacks. And probably you don't want to spend all your time fine-tuning it, right? So if I'm doing an attack personally, practically, I'm going to play with these parameters a little bit to see, roughly where the optimal configuration is, but I'm not necessarily hitting that, that perfect combination of parameters every time, because it takes time, right? To fiddle with it, and eventually you're going to be spending more time configuring it than you maybe even need to to run the attack. So this is the default engine that we're using, but of course you can also use some of the other engines. The one thing to keep in mind is that for some of the other engines, some of these attributes here, some of these configuration options are not supported. So for example, if you're using either of the burp engines, which would be burp or burp2, I don't think that requests per connection or pipelining are utilized at all. I think it's just looking at concurrent connections. Now for HTTP2, you can modify the concurrent connections and the request per connection. I'm not sure what pipeline does if it's used for anything, because again, if we're using HTTP2, HTTP2 uses multiplexing. It doesn't support pipelining, which is an HTTP1 feature. So I'm not sure if that parameter is used at all, but it works when it's true, so you might as well keep it to true. But the process is the same, right? You're using a different engine, but it's sending a certain number of requests per connection, and it's sending a certain number of, or initiating a certain number of concurrent connections. And you can go through the same trial and more trials process in order to refine those parameters. One thing to note if you're using the HTTP2 engine is it might be a little bit more painful to go through this process, because as you can see here, there's a little bit of a delay before that attack started where the engine warms up. Not sure exactly what it's doing there. It's doing something, but eventually it does get going, and this is pretty quick, but it's actually not as quick as we had with the other attack. And so probably, if I saw this trying both engines, I would just go back to the threaded engine. I think, I'm roughly happy with the speeds we achieved there, and I'd probably use it as is. But maybe you can get better speeds if you fine tune these parameters a little bit more, mess around with them. Keeping in mind, of course, that applications are all going to be different. The servers that are handling the HTTP or the HTTP traffic are going to result in different optimal parameters. Your networking setup. In fact, one of the other things that's actually mentioned in Kettle's article is that if you really want to speed up your attack, the geographical or at least the routing efficiency in terms of the network traffic is something to consider when you're targeting a server. So if you're connecting to a web application that is hosted on a server, on the other side of the world, maybe it makes more sense to set up a VPS in that region and then run on that system burp on the command line, because you can run Turbo Intruder from the command line. I believe there is an interface for that. I haven't used it myself. I think it is a feature built into Turbo Intruder that you can make use of for that scenario. But there is one other item in terms of efficiency to consider. So the other thing to consider is the computational load from the large number of responses that you're going to be getting and processing, right? So in addition to actually sending the requests, your system is receiving responses, and you're going to have a callback function, right? The handle response that needs to determine if this response is interesting and whether to include it in the table of results for you to look at. Now, you'll see that mine is very simple in this case. Right now, I just have whether the request status is not equal to the 404 HTTP response code. And this is the default, of course, in the basic.py example. Now, I'm going to make another video in the future looking at different ways of handling responses to find what is actually interesting. We're not going to look at that here. We're just going to talk about some of the ways in which you could implement handling or callback logic that will slow down your attack. So here it's very simple. We are just checking the status code of an HTTP response and determining whether or not that goes in the results table. However, even though the logic is relatively simple, because basically all of these requests return a 200, and here it's going to be slow again because I'm still in that HTTP2 engine that has to warm up. But as you'll see, all of the requests that I send, we receive all of the responses from those as 200, and therefore we put them all in the table here. So another thing that Kettle notes is that there is actually quite a bit of load from this specific function right here, adding the response to a table. So ideally what you want to do, and this isn't just for the computational load, but also to keep things easier for you to analyze, is you really want to reduce the number of responses that you're going to add to the results table. And how you're going to do that is going to obviously depend on the application and what you're actually trying to accomplish with your Turbo Intruder attack. But the simple recommendation in terms of efficiency is obviously to avoid very complex logic, right? Like regular expressions are going to be a little bit slower. Any type of iterative action, looping, that's going to be a little bit slower. This very simple conditional here is very efficient, right? So if you can do a simple conditional, hey, if it's equal to this status code, and that's only going to hit a few responses, that's going to be very efficient. But if you're doing much more than that, you might hit a bottleneck from a computational point of view in being able to handle and process all of those responses that are coming back. So that's, I think, almost everything you need to know about optimizing Turbo Intruder attacks. I'm very curious what you see in terms of optimal parameters. So please, if you're running these attacks against applications, whether it's bug bounty or you're doing pen testing, and keep in mind in both of those cases, obviously, to tread lightly, consider the targets that you're attacking and whether they have restrictions on the maximum number of requests you can send per minute, or if you're attacking a sensitive system that is in production that is critical, you may not want to conduct a Turbo Intruder attack that's going to put a lot of load on the system and potentially cause some impact. So keep that in mind. But otherwise, go wild. And hey, please post your results. Let me know what the optimal settings are that you're finding for different types of servers or technology. I'm sure there are lots of interesting insights to be had there. Happy hunting.